Hello everybody, this is the Congruence review for Integrated Math 1. I'm going to be solving every problem, but if you want to skip to a problem that you are stuck on, go ahead and check the description of this video. There is a link, a timestamp link to each and every problem. Let's get started on number 1. Classify each triangle by their angles and sides. Looking at A, I can see right away that two angles are both 72 degrees. And two sides are the same length, 4.8 feet, or whatever. So what that means is this is an isosceles triangle. An isosceles triangle has two equal angles and two equal sides. And then the third side and the third angle doesn't really matter. Looking at part B, this one has three equal angles, 60, 60, and 60, and it has three equal sides. And this is a very famous triangle. It is called an equilateral triangle. This is an equilateral triangle when all the sides and all the angles are the same. Part C. Looking at the three sides, they're all different. Looking at the three angles, they're all different, but there is one special angle, 90 degrees, forms an L shape. And when a triangle has a 90-degree angle, it's called a right triangle. Okay, looking at part D, these little red markings on the triangle means the angles are congruent, or they have the same degree measure, they're equal. So this triangle has two equal angles. Then the little tick mark on the side means these two sides are congruent, or these two sides are the same length. So if you kind of flip this one upside down, you can see that A and D are the same. This one has numbers, this one only has markings. This is an isosceles triangle because it has two equal angles or congruent angles and two equal sides or congruent sides. Part E. E is pretty similar to D with one little twist. You can see that there are two equal angles, two equal sides. So right away this is isosceles, because an isosceles triangle has two equal angles and two equal sides, but it also has a 90-degree angle. And anytime there's a 90-degree angle, you need to throw the word right in there. So this is, the most specific name is an isosceles right triangle. Right because of that 90-degree angle. And then taking a look at F, you're going to see that this one is similar to D. You have two of the same angles. The little arc means they're the same. And then you have this side congruent to that side. So what we have here is another isosceles triangle. Okay, for number 2, find the measure of each of the indicated angles. We're going to be using the triangle sum theorem, and that says 3 angles in a triangle must add to 180. So if we're looking at A, we have 20, 130, and question mark. Since we don't know what the question mark angle is, I'm going to give it a name, like X. X is the unknown. And then 20 plus 130 degrees plus X. Those 3 angles have to add to 180. Combining like terms, 20 plus 30 is 150 plus X equals 180. And then you subtract 150 from both sides. X equals 100 and, 180 minus 150 is just 30 degrees. So this is a 30-degree angle. Part B. Okay, we need another result, vertical angles. I call these the bow tie angles because they kind of look like a bow tie. Vertical angles are equal. Part B has vertical angles, even though it's twisted to the side. These two angles are vertical angles, so if this one is X, then the other one in the second triangle is also X. So there's two triangles here. The first thing we need to recognize is these two angles are the same degree measure. And then let's solve the bottom triangle, because we know that 20 degrees plus 40 degrees plus x has to be 180. These three angles are all in the same bottom triangle. Combining like terms, we get 60 plus x equals 180, and then you subtract 60 from both sides, x equals 120. Now we're not done yet, because we're supposed to find this question mark, but we're halfway there. So now let's look at the top triangle. There's three angles, 39, x, and question mark. But we just found x. Alright, so instead of writing x here, I'm going to say this is 120. It's 120 because this one's 120, and they're vertical angles from each other. Alright, and now I'm going to do the same program here. I'm going to call this angle y, because I already used x. And in the top triangle, 120 plus 39 degrees plus y has to be 180, right? The three angles in the top triangle have to add to 180. Combine like terms, this is going to be 159 plus y equals 180, and then subtract 159 from both sides. Y equals 21 degrees. And the y was the angle with the question mark, and so we are done. This one was 21 degrees, and then I'll leave this as 30 degrees. Part C. This little box means a right angle or a 90-degree angle. So this triangle has a 40-degree angle, a 90-degree angle, and let's call the question mark x. Solve for x. Let's use the triangle sum theorem, which says 90 degrees plus 40 degrees plus x. Those three angles have to add to 180. 90 plus 40 is 130, plus x equals 180, and then subtract 130 from both sides, x equals 50. So the answer there is 50 degrees. Part D, an isosceles triangle. I know this is an isosceles triangle because these two sides both have a tick mark. That means they are the same length. And if these two sides are the same length, then their opposite angles are equal. This side has an opposite angle. If you draw a little line that shoots out from it, it hits x. So that means this other side, if you draw a little line that shoots out from that side, the angle that it hits is also going to be x. Property of isosceles triangle, the two base angles are the same. Then we use the triangle sum theorem. 90 degrees plus x equals 180. So combining like terms, this is 90 degrees plus 2x equals 180. Solving for x, subtract 90 from both sides, and you get 2x equals 90 degrees, and then you divide both sides by 2, x equals 45 degrees. And that's what we are supposed to solve for, so the answer is 45 degrees. Part E. This one is similar. This side and this side are equal in length because they both have a single tick mark. So what that means is their opposite angles are the same. So this angle right here is 70 degrees, and the opposite angle to this side, if you draw a little line that comes out, it hits angle x. So again, this is isosceles. Isosceles triangles have two equal sides and two equal base angles. That means x has to be 70 degrees. No work to do there, you just have to memorize the properties of isosceles triangles. Part F. This one is similar to E. This triangle has two equal base angles, so right away we know it is isosceles. If you draw a little line that shoots out from this angle, it hits this side length 10, and same for the other angle, draw a little line that comes out and hits the opposite side. It has to be equal to this side, because it's isosceles, two equal base angles and two equal opposite sides. So again, no work to do there, you just have to know the definitions and properties of isosceles. Okay, looking at number 3. Find the measure of angle A. For this triangle, that's angle A. We're going to be using the triangle sum theorem again. 3 angles in a triangle must add to 180 degrees. So, looking at part A, there are 3 angles. This time, it's a little bit funny. The first angle, angle A, is x plus 61. The second angle is x plus 51. And the third angle is the only normal one, 80 degrees. So we've got x plus 61 plus x plus 51 plus 80. Since each of these is an angle, those 3 angles must add to 180 by the triangle sum theorem. So now we need to combine like terms. I have an x plus an x, that makes 2x. I have a 61, a 51, and an 80. Calculating. $192. So this is 2x plus 192. After combining like terms, and that's equal to 180. Alright, then we subtract 192 from both sides, and we get 2x equals 180 minus 192 is negative 12. Divide both sides by 2, and x equals negative 6. Now, you might be thinking, wait, negative 6? You can't have a negative degree measure. But this is not angle A. Angle A, the measure of angle A, is equal to x plus 61. So you have to plug in negative 6 to actually find out how many degrees angle A is. So this is negative 6 plus 61. And negative 6 plus 61 is 55. So after you plug in x as negative 6, the correct answer is the measure of angle A equals 55 degrees. And then we'll put a little note here, x was negative 6. Moving on to part B. Part B solved similar to A. You should watch A if you're stuck on B. I'm going to go through it a little bit faster this time. The 3 angles in a triangle have to add to 180. This little box means 90 degrees. So 7x minus 10 is our first angle, 3x is our second angle, and 90 is our third angle. And if we add those 3 angles together, they have to add to 180. So let's solve for x. Combine like terms, 7x and 3x makes 10x. And then let's see, we have a negative 10 and a positive 90. Negative 10 and positive 90 makes 80. And it's equal to 180 degrees. Then solving for x, subtract 80 from both sides, and you get 10x equals 100. And then x equals, divide both sides by 10, so x equals 10. Now this is not the answer, so be careful. The answer is, what is the measure of angle A? And the measure of angle A is 3 times x. The measure of angle A is 3 times x. So if x is 10, angle A is 3 times 10. Plugging in 10 for x, or just 30 degrees. So the measure of angle A is 30 degrees. And we'll make a note down here, x was 10. Last one is C for problem 3. Triangle has 3 angles here, 134 degree angle, a 5x plus 2 degree angle, and a 6x degree angle. So if we add these 3 together, 5x plus 2 plus 134 plus 6x. Those three angles should add to 180. We combine like terms to solve for x. 5x and 6x makes 11x. Then we have 2 and 134, both positive, so that makes 136. That's equal to 180. Subtract 136 from both sides, and we get 11x equals 180, let's see, 7, that's 10, so that is 44 degrees. Divide both sides by 11, and you've got your x, which is 4. Now that is not the answer. The answer is the measure of angle A. And the measure of angle A is 5 times x, and then add 2. So this is going to be 5 times 4, and then add 2. 5 times 4 is 20. 20 plus 2 is 22 degrees. That's our answer. The measure of angle A, you have to plug in x to find it, is 22 degrees. Problem 4. Assume the two triangles are congruent. Triangle XYZ congruent to triangle LMN. Here's our congruent statement. Find the measure of the unknown angles. Let's take a quick look at the definition of triangle congruence. If two triangles are congruent, what does that mean? That means that all of their corresponding sides and angles are the same. And the word corresponding, if you don't know what that means matching. Okay, so let's look at our two triangles. They're congruent. They are the same. So that means this angle with a single arc, which is angle M, corresponds in the other triangle with that angle with a single arc. So these two triangles are congruent, so that means these two angles are the same. They match. These are the corresponding parts. Angle M corresponds to angle Y. Angle Y is 88 degrees. Okay, then we have this angle here, which is Z. Z is 50 degrees. So we go to the other triangle. We go to the blank angle, right? Because this one has two lines. That one has two lines. So X and L go together. That means Z and N go together. And maybe I'll have these with 3 lines. So that means angle N is 50 degrees because the triangles are congruent. So the corresponding angles are the same, or the matching angles are the same. All right, and then we go to angle L and angle X. These ones are corresponding because they both have the two lines and the triangles are congruent. So L and X are going to be the same degree. We don't know what this is, so I'm going to call angle X X, which makes sense, and then use the triangle sum theorem. 50 plus 88 plus X. Those are 3 angles in the left triangle. Those 3 angles must add to 180. Solving for x, 50 plus 88 is 138, plus x equals 180, and then subtract 138 from both sides. X equals 42. So angle X is 42. That also means angle L is 42 because they are corresponding angles. Number 5. Find the measure of angle BDC. Explain your reasoning. With these kind of problems, it's best to redraw it because it's really kind of confusing. Here's what's going on. We have a triangle. This is triangle A, C, D. This angle up here is 45 degrees. And then, let's see, this angle down on the bottom right is 30 degrees. And then we don't really know what this angle C is. Let me write the letters out. This is A, D, and C. Okay, So I'm splitting this into two triangles, if you're confused what's going on. These two triangles are kind of like stacked on top of each other, which makes this problem more difficult to solve. So if you redraw it, now we've got two triangles. You can see that if I move this one over, it will be on top of it and basically the same thing. Alright, so triangle B, CD. So in this triangle right here, we have this angle C having two lines, which means it corresponds to this angle D. They're matching, so they're both 30 degrees. They have the same degree measure. And then also notice that this angle B has a single red line, which means it matches with a single red line in the other triangle, 45 degrees. Okay, so right away we can see that angle BDC, right? Angle BDC. BDC is this, I'll make it green, this angle right here. I'm going to call it X. And just like the other problem, 45 plus 30 plus X, these three angles must add to 180 degrees. Alright, so 45 plus 30, that adds to 75, combining like terms. And then solving for X, subtract 75 from both sides. X equals 105. Okay, so that was angle BDC. So the measure of angle BDC is 105 degrees. Number 6. For A through D, triangle XYZ is congruent to triangle MNL. Copy and complete the statement. Use the figure shown at the right. Let's remind ourselves the definition of triangle congruence. If two triangles are congruent, then all of their corresponding sides and angles are the same. Corresponding means matching. Okay, so this one's a little tricky. The way you have to tell is the ordering of the letters. So because X and M are the first letter in each congruent statement, that means angle X is congruent to angle M. Then the second letter are Y and N. So angle Y is congruent to angle N. So the ordering is important. Then the third is Z and L. So angle Z corresponds to or is congruent to angle L. And then we're going to do the same thing with the sides. So now we look at two letters. The first two letters of this are X and Y. Before we do that, let's mark this up. So angle X and M are corresponding. Angle Y and angle N are corresponding. And angle Z and L are also corresponding. Alright, can we find any of this information yet? Let's see. Angle Y corresponds to N. N is 124. So that means angle Y is also 124. Then let's look at angle M. Angle M corresponds to angle X. So because angle X is 33, angle M is 33. Degrees, of course. And then to get angle Z, we have to notice that we know two of the angles in the triangle. So we can find the third angle using the triangle sum theorem. Let's call angle Z, let's call it Z actually. Let's add these three together, 33 plus 124 plus Z. And if we add these three together, it has to add to 180. Solving for Z, combine like terms, that's 157 plus Z equals 180. And then you subtract 157 from both sides. And Z is 23. So this Z is 23, and then the measure of angle Z is 23 degrees. Alright, last, looking for XY. XY I'm going to erase all the angle stuff to make it neater. XY is this side, and it's the first two letters of the triangle in the congruence statement. The first two letters of the other triangle are MN. So because of the ordering of the letters, XY is congruent to side MN. Now because side MN is 8, side XY is 8, because they're matching, due to definition of congruence. So there's your answers. Number 6 is done. Number 7, identify all pairs of congruent corresponding parts. Then write a congruent statement. Let's start with the sides. Side AC has a single tick mark. If we go to the other triangle, that's going to be corresponding to side FH. So side AC is congruent to side FH. Then let's look at the side with two tick marks. On the first triangle, that's AB. FG has two tick marks, so side AB is congruent to side FG. Next and last, the side with three tick marks. Side BC in this triangle corresponds to side GH in the other one. So side BC is congruent to side GH. Now that the sides are done, I'm going to erase my marks on the triangles, and let's do the angles. Angle A is 90 degrees, angle F is 90 degrees. So angle A is congruent to angle F. Now I could write like the 3-letter version of the angle, like angle CAB, but that's kind of annoying, and since the two triangles are separate, they're not touching, I can write the 1-letter version of the angles. And it's much cleaner that way. Angle B in the first triangle corresponds to angle G in the second triangle. They both have a single arc. So angle B is congruent to angle G. Last angle is H and C. Both of them have two arcs, which means they are corresponding and congruent. Angle C is congruent to angle H. So when we write our congruent statement, the order is important. I'm going to start with this triangle and go in alphabetical order. A, B, C. Triangle symbol is the little triangle, triangle ABC. And if you notice the order, I went from the 90-degree angle across the side with two tick marks, then across the side with three tick marks. So in this triangle, I'm going to start at the 90-degree angle and go across the side with two tick marks, then go across the side with three tick marks. You got to go in the same order. So that's FGH. Triangle ABC is congruent to triangle FGH. Number 8. Determine whether or not the triangles are congruent. If so, write a congruent statement. Name all the special properties or theorems you use to reach your conclusion. For example, the reflexive property, the definition of bisection, vertical angles, etc. Okay, part A. Angle A is congruent to angle Q, angle B is congruent to angle R, and side AC is congruent to side QS. I'm going to mark up this diagram, starting with angle A is congruent to angle Q. Those two angles are the same, so I'll give them a single arc. Angle B is congruent to angle R. Those two are the same, so I'll give them a blue double arc. They match. They're corresponding. And side AC is congruent to side QS. Since we're talking about sides, I'll put a tick mark. Side AC and side QS. I'll put them both having a single tick mark. So these triangles are congruent by a certain congruent condition. We have an angle. Those two angles match. These two angles match, and these two sides match. This is angle, angle, side. The side is not included between the two angles. So these two triangles are congruent by AAS congruency condition. Now we need to write a congruence statement. So I'm going to say ABC, triangle ABC. The order is important. So if I say ABC, I have to say QRS, triangle QRS. So there's if they're congruent or not, and then this congruence statement. Part B, HK, side HK is congruent to side JL, and side HJ is congruent to KL. A little confusing here. HK and JL match, so side length HK and JL match. And then we have HJ and KL. I'll do that in blue and put 2 tick marks for HJ and 2 tick marks for KL. Those sides match. Now we do have a third matching side. Since the triangles are touching, we do have KJ is congruent to KJ. This is by the reflexive property. When two triangles are touching, you can say that this shared side is common between the two triangles, so it's congruent to itself. This one's a little strange. You don't have to draw this, but just to help you understand, if you cut these two triangles apart, then you would only know the blue and the red sides are matching. The only way you know that these two sides match is because originally these two sides were touching. So they're the same length. They overlap each other, so if you split them apart, they're still the same length. And the property is called the reflexive property. That tells you that. This side is equal to itself. Okay, so these two triangles are congruent. They have side, side, and side corresponding to each other. So they are congruent by the SSS congruency condition. And then to write the congruent statement, if we say HKJ, triangle HKJ, congruent to HKJ, so that would be LJK, LJK, triangle LJK. Make sure you go in the same ordering for each triangle. All right, part C. PQ bisects angle SPT. Side SP is congruent to side TP, and then that's all they gave us. Bisects means cuts in half. Side PQ cuts in half angle STP. So if we find angle STP, angle SPT is here, angle SPT, that's this guy, this big angle. We ignore this little line down the middle. So angle SPT is that angle. But side PQ is going to cut that angle into 2 equal parts. It's going to cut it in half. So what that tells us is this half of the angle and this half of the angle are equal. So I'm going to erase some stuff, and I'm just going to write it like this. Those two angles are matching. One angle is from the left triangle, and the one on the right is for the right triangle. Okay, side SP is congruent to side TP. So that means side SP and TP are corresponding. I'll give them both a single tick mark. Now we need to use the reflexive property again to say that PQ is congruent to PQ by reflexive property. So I'm going to draw on side PQ a single line with 2 tick marks. Let me explain it again. You don't have to draw this next part just to help you with the explanation. So if you were to split this triangle down the middle into 2 triangles, we know the red angles are the same between the 2 triangles, and we know the blue sides are matching, but the only reason we know that PQ and PQ are matching is because originally they were touching and they were the same side. So if you cut it apart, these 2 sides will have the same length. This is the reflexive property. If 2 sides are touching, then they have the same length for each triangle. So these 2 triangles are congruent. We have a side, an angle, and a side. That's SAS. The angle is included, or it's in between the two sides. So it's congruent by SAS congruency condition. Let's write a congruent statement. Triangle PQS is congruent to triangle PQT. This isn't the only possible answer, just make sure you go in the same order for each triangle. Choose the correct congruent statement given the triangles below, number 9. Then name the postulate you would use to prove them congruent. Okay, so let's look at these two triangles. We have these two sides corresponding, these two sides corresponding, and those two sides. This is going to be SSS congruence. So let's choose the correct one. It has to be in the right order. HFG. That's H, then F, then G is corresponding to K, I, J. That looks like it went in the same order, so that's promising. But let's try the other ones just to make sure. GHF kind of goes that way. And on the other side, it's KJI. These clearly aren't going in the same order, so I'm going to cross that one off the list. And let's try the next one, GHF. It goes in that order, congruent to KIJ. So that is KIJ. Also not correct, because on the right I started with G, and on the left I did not start with angle J. I mean, those two are corresponding together, so you can see that it's different ordering for part C. Lastly, part D, FGH, FG and H, it goes in that order. So KJI, does it go in the same order? And the answer is no, because I'm starting at the bottom for this triangle, and on the other triangle I started in a different location. So the only correct ordering is HFG and KIJ. Both of those have the same ordering. You start at K, then go to the angle on top, then go to the angle in the middle. By SSS congruence. Number 10. Given side SE bisects angle LEG and side LE is congruent to side EG, choose the correct congruent statement. Then name the postulate you would use to prove them congruent. Let's break this down. Bisects means cuts in half. So side SE cuts in half angle LEG. Let's find angle LEG. Angle LEG. So this is angle LEG. It's this big angle that goes in between the triangle on the left and the triangle on the right. And the red side SE is going to chop that angle in half. Chops it into two equal pieces. So that green, giant green angle becomes two little angles. Alright, so LEG was the big one, and now there's two angles, but they're both the same. That's what bisects tells us. Both of these red angles have the same degree, because originally they were part of a larger angle that was split in half. Side LE is congruent to side EG. Okay, so side LE and EG are the same, so I'll put a single tick mark for those two sides. They match. Alright, and then lastly, we need to use the reflexive property. So because the triangles are touching, side ES is congruent to side ES, and that is the reflexive property. And then you don't have to write this part, this is just for your knowledge. If you were to cut the triangles in half down the center line ES, you'd get these two triangles shown here. And you can see that the only way we know that these two sides are the same length is that they were originally part of the same triangle. They were joined together. So when you cut this in half, these two sides stay the same length, and that is by the reflexive property. For the left triangle and the right triangle, the sides are the same. So we have a side in common. We have two angles in common, we have another side in common. So this is SAS. The angle is included in between the two sides. It's right in the middle, right where the two sides meet. They meet at this point, and that's where the angle is. Now let's find the congruence statement. Angle LES, I'm going to erase all my marks. Let's see, angle LES and ESG. So LES goes this way, and ESG goes that way. Those are not in the same order, so this is not a correct congruence statement. For part B, SLE, so we start at S. For the other triangle, it goes GSE, and right away I can see that these are not going in the same order. This one started at S, and the other one started at G. Part C, SLE is congruent to ESG, so that is SLE is congruent to ES. These are not in the same order, so again, cross that one off the list. Last one is D, ELS, from the top to the left to the bottom is congruent to EGS, from the top to the right to the bottom. And I hope you can see that these are in the same ordering. They follow the same pattern. Number 11. If you're given two triangles, triangle MNP and triangle QRS, where side MN is congruent to side QR, side NP is congruent to side RS, what additional information would be sufficient to prove triangle NPM is congruent to triangle RSQ? Hint, draw a diagram. Okay, I'm going to draw a diagram on this because that was the hint. So I have triangle M, N, P, and I had triangle, I'm going to make sure I go in the same order, Q, R, S. We know MN and QR are the same. They correspond. So I'll put a single tick mark on those sides. And NP and RS correspond. Double tick mark on those sides. And this is not enough info to prove them congruent. So we need one more piece of info. And let's try A. What if R and P were the same? So here's R and here's P. Would that help? No, because look at angle R. If angle R and N were the same, that would be helpful. But angle R and P are in different locations. Whoops. So that's not going to help us because the angles are in different spots. Now let's try B. Angle S and angle P are right angles. So angle S is 90 degrees and angle P is 90 degrees. Let me redraw these triangles because now these are 90 degrees. So I want to make them look more accurate. So we have M, P, N, and Q, S, R. We still know that MN and QR are the same length as given. And we know that these two, NP and RS, are the same length. But now we know that P and S are both 90 degrees. So let's see what we have here. We have that these two sides are congruent. These two sides are congruent, and there's a 90-degree angle. Let's try it HL. So, do we know the hypotenuses are the same? Hypotenuse, it's right across the 90-degree angle, and the answer is yes. Both of these hypotenuses have the same length. They match. Then, let's check if there's another side that matches. And there is. This side matches. And so in a right triangle, we call these legs. L stands for leg. So we can actually use HL, which is one of the more confusing ones. If the hypotenuses of the two triangles match, and if one of the sides or legs matches, and there's a 90-degree angle, that proves the two triangles are congruent by HL. So B would help us prove that these two triangles are congruent by the HL congruency condition. If triangle ABD and CBD are right triangles and side length AB is congruent to side length BC, what theorem or postulate proves triangle ABD is congruent to triangle CBD. Okay, so let's mark up the diagram. ABD and CBD are right triangles. So that means that we can add 90-degree angles at these two locations, since they're right triangles. Then we know that AB and BC are congruent. So here's AB, and here's BC. They're the same, so I'll put a tick mark. We also know, look, the triangles are touching. So because the triangles are smushed together, the side in the middle, BD, is congruent to itself. This is by the reflexive property. So we can add in 2 tick marks. And let's figure this out. When there's a right angle, it's always a good idea to check HL. So going opposite of the 90-degree angle on the left triangle, that hypotenuse actually is congruent to the other hypotenuses. So we're off to a good start. The hypotenuses between the two different triangles match. Then these two sides match, which we call legs in a 90-degree triangle, a right triangle. So we have a hypotenuse match, we have 2 legs match, and we have a 90-degree angle. And that is classic hypotenuse leg. Answer A. You can see that it's not D because we only have 1 pair of angles, and ASA requires 2 pairs of angles. You can see that it's not C because we don't know any information about the third side. We only know 2 sides match, so we don't know that 3 sides match. We can't use SSS. And then for SAS, if we wanted to use SAS, the angle would have to be between the 2 sides for SAS. So the angle would have to be here and here for SAS, which is not the case. Angle is an R diagram down at the bottom, not included between the 2 sides. Number 13. If side HG is congruent to side KG, and angle HGJ is congruent to angle KGJ, which congruence postulate or theorem would prove triangle GHG is congruent to triangle GKG? Lots of letters here. HG and KG are corresponding. These are sides. So if I find HG and KG, I can give them both a single mark. Those are corresponding or matching. Then we have HGJ. Let's find that. HGJ is congruent to KGJ. So that is KGJ. So what that means is this angle on top and this angle on the bottom are the same. Getting rid of the highlights, those 2 angles are the same, and then the third piece of info comes from the fact that the 2 triangles are smushed together right alongside JG. So because they're smushed together along JG, we can include that as a side by the reflexive property, which says if 2 triangles are touching or share a side, then the side is congruent to itself. So we have a side, an angle, and a side in that order. That's SAS. Clearly we can't use SSS because we don't know anything about the third side. We can't use HL because there's no 90-degree angle. You need a 90-degree angle to use HL. And then we can't use AAS because we only know that 1 pair of angles is matching. To use AAS, we would need to know 2 pairs of angles are matching. Okay, number 14. State what additional information is required in order to know that the triangles are congruent for the reason given. Alright, so I want to use ASA. Okay, and what do I know? I know that these 2 angles are congruent, and then I also know that XY is congruent to XY. It's congruent to itself, so I'll add a tick mark in the middle, and that is by the reflexive property. So because the triangles are touching or have a shared side, that side is congruent in each triangle. Now I want to use ASA. So if I knew that these two angles were matching, then I could say ASA on both triangles. The side is included in between the two angles, and I could use ASA to do that. So what additional information is required? I need to know that this angle and that angle are the same. It's not given. I had to add that in myself. Right? The reflexive property is given. The bottom red angle is given. So what did I add? I added ZXY, angle ZXY is congruent to angle UXY. Angle UXY. That's what I had to add in order to be able to use ASA. Now, if you're wondering why I use the three-letter combo for the angles, since this is X and since the triangles are touching, I can't say angle X is congruent to angle X. That's not very specific. What does that even mean, right? So that is why I had to use the three-letter version to differentiate the angle between the two triangles. B. I want to use SSS, but look what I have right now. XY and JI are corresponding because they have a single tick mark. YZ and JK are corresponding because they have a double tick mark, but I don't know anything about XZ and IK. So if I add in that information, if I add in that these two sides, then I could use SSS, right? So what did I have to add in? I had to add in that XZ, side XZ, is congruent to side IK. Once I add that in, now I can use SSS because we have side, side, side corresponding between the two triangles. So it's all about what you have to add in yourself to be able to use the given postulate. Okay, last one for 14 anyways. We have that side DW and side VW are congruent because they have a single tick mark. We can also use the reflexive property. The triangles are touching, so the side in the middle is shared between the two triangles on the left and right. So side XW is congruent to side XW by the reflexive property. Now, even though I added the tick mark, that doesn't count as like adding in extra information. We already knew that information. We just had to find it. The reflexive property is always like given information, right? So I want to use SAS, but the problem is there's no angles that are corresponding. We can't use vertical angles. We can't do anything like that. So I need to add in an angle right here. Side, angle, side. That would put the angle right in between or included between the two sides. So if I knew that this angle W was congruent to this angle W, then I could use side, angle, side. But again, I don't want to say angle W is congruent to angle W because that's not specific enough. So to get specific, the angle W on the left, named with 3 letters, would be DWX. Angle DWX. You put the angle at the center, or the vertex, right in the middle of naming it. And that would be congruent to angle VWX. Angle VWX. Again, you put the angle vertex in the middle of naming it. And so that's what I would need to know. I had to add that into the diagram in order to use SAS. Number 15. Use triangle congruence condition to decide whether or not each pair of triangles is congruent. If so, state the postulate. Base your decision only on the markings, not how the triangles look. So let's look at part A. I can see that these two sides are corresponding to each other. I can see that these two sides are corresponding to each other because they both have 2 tick marks. And the angle right in the middle between the two sides, right, it's right where those two sides meet. Those two angles are corresponding. And this is classic SAS. The angle is included between the two sides. It's right where the sides meet. Part B. I can see that these two sides are corresponding. I can see that these two sides are corresponding, 2 tick marks. And I can see that these two sides are also corresponding for the 3 tick marks. So that's an S, and another S. SSS congruence. All 3 sides are the same, so the triangles are congruent by SSS. Part C. These two angles are matching. And then this one's kind of weird. These two angles are matching. It has a tick mark. This one doesn't have a tick mark. And then the side is matching. So we have an angle, and a side. Now this side is not in between the two sides. ASA is where the side is in between the two angles, So we can't use ASA, but what we can use is AAS. And here's why. We have an angle, and the side that matches is not included, or it's not in between the two angles right here. So that's how you know to use AAS. AA and then an S off to the side. That's why the letters go AA with the S at the very end. Okay. In D, these two sides are corresponding. These two angles are corresponding. And because of the way they're marked, these two angles are corresponding. So if you notice, in this triangle, it's actually ASA because the side is in between the two angles. And in this triangle, the side is not in between the two angles. Kind of a trick question here. This is AAS, where the side is not included. So for D, we have not enough information for D because the way the triangles are marked are different. E, I see a right 90-degree angle, so I'm going to check for HL. 90 degrees, 90 degrees. First, let's find the hypotenuses. That's my hypotenuse. And this is my hypotenuse, and they both have a single tick mark, so they match. Then we have that these two sides are congruent, and we call these sides legs for a right triangle. And so we can use HL. The hypotenuses match, the legs match, one pair of legs match, and there's a 90-degree angle. Part F. This side and this side are corresponding. Because of the single tick mark, this angle and that angle are the same, and this angle and that angle are the same. So you can see that even looking at it, it's ASA. The side is included in between the two angles. And on this one, it is also ASA because the side is included in between the two angles. Review systems of equations. Solve the system of equation. Part A. Y equals 7x minus 21. Y equals 2x minus 1. So the first thing I notice is both in y equals form. So I'm going to use something called the equal values method. Y is equal to 7x minus 21, and y is equal to 2x minus 1. So I can set these two equations equal to each other, or in other words, you just put an equal sign in the middle. Then solve for x. Looking between the two sides, 2x is smaller, so I'm going to subtract 2x from each side. So that's going to be 5x minus 21 equals negative 1. And then add 21 to both sides, and I get 5x equals 20. Divide both sides by 5, x equals 4. Now I'm halfway there. Now I have to pick one of the original equations. I'm going to pick the bottom one, which looks easier. I have y equals 2x minus 1, but now x is 4. So y is just 2 times 4 minus 1, which is just 8 minus 1, so y is 7. So my answer as coordinates is 4, 7. Part B. It's the same, both are in y equals form, so equal values method. Y equals 3x plus 19, y equals negative 2x minus 6. So what I'm going to do is set the two equations equal to each other, or in other words, put an equal sign in the middle. Okay, then I look for the smaller of the two x's, which is negative 2x. Let's move that to the other side. I can move that to the other side by adding 2x to each side of the equation. It becomes 5x plus 19 equals negative 6. Then I subtract 19 from each side. 5x equals negative 25. And then divide both sides by 5. So x equals negative 5. Then I pick an equation. I'm going to pick the bottom equation again. Plug back in x equals negative 5 to solve for y. Y equals negative 2 times x minus 6. So y equals negative 2 times negative 5, subtract 6. Negative 2 times negative 5 is positive 10. Negative times a negative. And then if you subtract 6 off of that, you get 4. So the solution, x comma y, negative 5 comma 4. Next, the x, neither of these equations is solved for y. They're both in standard form. X is on top of x, y is on top of y, so I'm going to use elimination. So I can see that the x variables, they have opposite signs, but they don't have matching coefficients. So what I want to do is change this into a 12x, a negative 12x. So what do I need to multiply the bottom equation by to do that? It'd be 4, right? If I multiply the bottom equation by 4, then I would get negative 12x. The top equation stays the same. And then if you multiply everything on the bottom by 4, I get negative 12x minus 28y equals 4 times 28 is 112. Now we add the two equations together. 12x minus 12x cancels. And then over here, adding together gives us negative 32y equals 128. Divide both sides by negative 32, and y is negative 4. Now we need to pick an equation to plug this y back into to solve for x. Neither of them looks that easy. I'm going to pick the top one because there's less negative signs. So we have 12x minus 4y equals 16. That's 12x minus 4 times negative 4 equals 16. Okay, so 12x, negative 4 times negative 4 is plus 16. Equals 16. Subtract 16 from both sides, so we get 12x equals 0. A lot of people write no solution here, and that's wrong. It's not no solution. Divide both sides by 12, and x equals 0. 0 divided by anything is 0. So our answer in coordinates is 0, negative 4, x, y. Part D. I'm also going to use elimination here because neither equation is solved for y. And the x is on top of x, the y is on top of y. So the x's and y's both have opposite signs. One's positive and one's negative. But I think it'd be easier to eliminate y. So if this term on the top were negative 8y, then we'd have a negative 8y and a positive 8y, which would eliminate. So what would I need to multiply the top equation by to turn that into a negative 8y? It'd be a 2, right? So let's do it. 2 times negative 5x is negative 10x. 2 times negative 4y is negative 8y equals 8 times 2 is 16. Keep the bottom equation the same. And now let's just add the two equations together. Negative 10x plus 4x is negative 6x. Negative 8y plus 8y cancels, it eliminates, and that's equal to 16 minus 16, which is 0. Negative 6x equals 0. Divide both sides by negative 6, and x equals 0. 0 divided by anything is still 0. Okay, so I'm going to plug this back into the bottom equation because it looks easier to me that way, to me at least. So we have 4x plus 8y equals negative 16. That's 4 times 0 plus 8y equals negative 16. And then 0 times anything is just 0. So this is gone. 0 plus 8y is just 8y equals negative 16. Divide both sides by 8 and y equals negative 2. So my answer as coordinates is 0, negative 2. Last one, number 18. Multiply the following. Part A, 5x plus 4 times 4x minus 1. If you forgot how to do these are solved by drawing a box. You can also use the FOIL method, but I will not demonstrate that in this video. Okay, so this 5x plus 4 is 2 terms. 4x minus 1 is also 2 terms. So I'm going to draw a 2 by 2 box. On one side of the box, the top row will be 5x, the bottom row will be plus 4. And then on the bottom of the box, I have 4x for this first column, and then negative 1 for the next column. And then we multiply to fill in the numbers in the middle. So let's multiply. 4x times 4 is 16x. 4x times 5x is 20x squared. Don't forget the x squared, because x times x. 4 times negative 1 is negative 4, and then 5x times negative 1 is negative 5x. So this is equal to 20x squared plus 16x minus 5x minus 4. You add these all together. Don't forget to combine like terms. So this is equal to 20x squared plus 11x minus 4. And that's my answer. Part B. You can draw the box, but because this is just a single term right here, it's easier to use distribution. So distribute the 3x. 3x times x is equal to 3x squared plus 3x times 1 is 3x. Part B is done. Part C. I have a polynomial which is 2 terms, and it's multiplying a polynomial which is 3 terms. So I'm going to draw my box. Let's multiply the polynomials. And in my box, I'm going to make it 2 by 3. 2 because we have an x and a plus 4, and then 3 because we have an x squared, a 3x, and a 1. So let's multiply to fill in the grid. X squared times 4 is 4x squared. X squared times x is x to the power 3. It's not 2x squared. It's a common mistake. 3x times 4 is 12x. 3x times x is 3x squared. 1 times 4 is just 4, and then 1 times x is x. So when you multiply these together, this is equal to x to the power 3 plus 3x squared plus 4x squared plus 12x plus x plus 4. Don't forget to combine like terms. We have two pairs of like terms here. So it's x to the power 3 plus 3x squared and 4x squared make 7x squared plus 12x and x make 13x. Final answer.